I've made this matrix panel display board, matrix display board. Just switch it on. What does it do? It provides you with lots of unhelpful information. Connects to the internet, uses APIs to get data from various sources. I've got background tasks downloading traditional files, as well as kind of scraping. There's one of them that scrapes the web page. What I'll do in this video is go through what all the 9 functions that it does. Yeah, it's flickery that, isn't it? So there's PHP backend, there's Python scripts for importing, and there's C++ or Arduino style code for the microcontroller. I'll turn this background off because it's distracting. Yeah, I tried all sorts to try and get rid of the shimmer on the camera, but it won't play nice. So, first page, button 1. It's the weather. This weather comes from openweathermap.org. Kind of saves me looking out the window. That's it really. Next. Number 2 is airlines, aircraft in the sky. So 150 nautical miles radius of my home. What we got, this is from ADSB1. So call sign, operator, aircraft type, altitude, speed, and again the cardinal from the heading. Because they provide the latitude and longitude, I can work out how far away it is from me, and the town or village or whatever it is flying over at the time. Number 3, trains departing. So I've chosen random stations, so the top 20 busiest stations in Britain are used for this data set to display here. I used to have it on my own station in Sheffield, but it got a bit dull after a while. You just see the same trains all the time, so I've changed it to a random one, so every so often it'll change to a different station. 4, that's trains arriving in Vauxhall. It's near London, I think. Same as departing, trains arriving. 5, yeah, this train data comes from National Rail. Number 5, satellites. So satellites overflowing my home at this time. This is using a TLE or 3-line element data set from Celestrak. Kind of like just showing the speed of the satellite relative to Earth, I think. How far away it is from me, the heading, whether it's going away or towards, and then where it's overflying at the moment. Number 6, shipping forecast. 6. Yeah, shipping forecast. This comes from the BBC, Radio 4. It gets read out 4 times a day. If you don't know the shipping forecast, around the British Isles, the island is, there's like 31 sea areas, and also down into the Bay of Biscay and around Portugal, I think, and possibly down to Spain. These are kind of like, every so often there's like a synopsis or a summary of each shipping area as we go around. It's kind of like a British, it's a tradition, been going since the 1930s. I think if the BBC stopped doing this sort of thing, people in the home counties would write angry letters. Number 7. This one's a bit slow because it's a beta service from Environment Agency. Uses the real-time flood monitoring API. So at the moment not a lot's happening. I think this page needs to be made more interesting. I probably won't use this one very often. 8, buses. 8. Right, so buses. This uses the Department of Transport find a bus or find bus open data API. Clunky name. I've also combined this with the NAPTAN bus stop database to give me some additional information. So the open bus gives me the route number, the bus, where it's going from to the operator, as well as the latitude and longitude of the current location of the bus. So then I use that in conjunction with the NAPTAN data to find the nearest bus stop. Because this data is completely kind of like, by the time you see it and you got to page 10 or whatever, the bus will have moved on. I needs more width as well. On for this one, shipping. Those ships passing through the Straits of Dover. This data comes from AIS stream. It only gives a very basic information. The paid services obviously add a lot more data to this sort of thing. I think that was German. So speed in knots, heading, and then the ship name. I can also do Strait of Gibraltar. Most of the ships are on the Spanish side because that's where all the receivers are, the AIS receivers. So the Moroccan side tends to be a bit quiet. And I'll do the hardware. There's not a lot of hardware, not a lot to see. Right, so the matrix panels came from a 64 by 64. They came from Pi Moroni as a supplier. Probably our cheaper way places to get them from. So power comes in, 5 volt 5 amp buck regulator into these Wago style terminals, not actual Wagos. That then gives me power down here and under here, 5 volts directly, and also to the board. This board's got a 3.3 volt power supply here. That powers all the components, all the parts on the system here, so that the Wi-Fi board is a Wink 1500. The microphone isn't being used. There's a little buzzer, LED, a photo transistor, which I've not written code for at the moment. I'd normally use those on this sort of projects. I'd use this to monitor the light levels, so if the room goes dark then I'd have the thing go into a low power mode, assuming that you've kind of gone to bed or something. And that's for the remote control. Teensy 4.1 Arduino start compatible, and down here this is a smart LED Teensy 4 matrix panel display board. It's got logic level converters and everything built into it. Right, that's it hardware. Oh yeah, 3D printed out some supports to hold everything in place so it doesn't flop around. Right, so the next stage will be the software.